Okay, let's see the another example. Graph. Here is the graph is given here again, and they say find the VT graph. The displacement time graph is given. So first we find the velocity from this graph, and then we draw the VT graph or velocity time graph. Let's see how. Like in the first second again, they cover 5 meter, and second they covered 10, and third they covered 15. So if we join, so it gives us the slope. So this slope means it gives us the velocity. Now this velocity is equal to again xt divided by delta t. Now putting the value like this, the x of I, this is the x of f, and this is the t of I, this is the t of f. So this delta x is equal to xf minus xi, and this delta t is equal to tf minus ti. Now putting the value here, xf is equal to 15 minus xi is equal to 5. Now the time tf is equal to 3 minus ti is equal to 1. So this is equal to 10 meter divided by 2 second. So now this is equal to 5 meter per second, which gives us the velocity. Now this is the first part that we find the velocity. Now how can we find the VT graph? Here it's very simple. VT graph mean like on the vertical side we must have velocity, mean meter per second, and on this side is time. Let's suppose we have 3 seconds or more, 1, 2, 3, 4, and so on. So this means that in every second the velocity is constant here, and this velocity is how much? 5 meter per second. So this means this will make the straight line like this. Mean in first second the velocity is 5 meter per second, and second the velocity is 5 meter per second, and third, and so on. So this is the VT graph. Okay, let's see the another example. Area under VT graph gives us displacement. Like in the previous page we already discussed, if we have the graph like this will gives us the displacement. For example, if we join or combine this part or this, so here the rectangle is made, and this rectangle area is equal to delta x or displacement. Like how? We know that velocity is equal to delta x divided by time. So now if the velocity is given and time is also given, like in vertical side is velocity, this is given, and horizontal time, but the displacement is not given. So then we can find the displacement like this, multiplied both sides with t. So t multiplied by v is equal to delta x, or simple we can write this delta x is equal to vt. So this gives us the displacement, or this area will be equal to displacement. Now let's see again another example. For example, here the velocity is 9 meter per second. The velocity is given and the time is also given, which is equal to 4 seconds. So first we find the displacement like this. Displacement, we know that displacement is equal to Vt. So now the velocity is 9 meter per second, and time is multiplied by 4 second. So second will be cancelled with second. So 9 multiplied by 4 is equal to 36 meter. This is delta x. So this will gives us the displacement. Now they said they draw the xt graph, mean displacement time graph. So it's very simple. the time is how much? 4 seconds, like 1, 2, 3, 4. Now the difference here is like 9. 1, 2, 3, 4, like in 1 second 9 meter, and second 18 meter, and third 27, and fourth 36. So this graph will show us the xt graph or displacement type graph. If we join these different part, so it gives us the velocity like this. So this graph is called displacement time graph, or simple we can say delta x time graph. Okay student, so this is all about the velocity, speed, instantaneous velocity, and the different graphs that we already know, the velocity time graph, displacement time graph, and so on. So if you have any difficulties or any problem related to the following terms, velocity, displacement, and so on, so you can ask in through it by the comments. So thank you so much for today's lecture.